So continuing on with our project today, we're going to make the bearing roller for the crankshaft touring station. Digging through the scrap pile out behind the shop here, I found some 1/4-inch aluminum plate, and it's going to be pretty much perfect for this project. And would you believe it, I actually have the proper blue layout die in the shop for a change. I mean, last time you guys had given me heck for using paint, so we got on KBC and we actually ordered the right stuff. And I'm pretty much loving this stuff. It's working pretty good. So like I said earlier in this whole project, we're kind of building this as we go. So we're going to do this blueprint as we go, and 2.5 inches seemed just right for fitting onto those castings that we made. And then we're going to add an additional layout line for the 1/8 inch thickness of the blade, because we're actually going to take this downstairs and cut it on the table saw. Now, some of you guys might be looking at this like it's Bush League, and believe it or not, it actually works pretty much like you're cutting oak, except these little shards that are coming off there come off like red hot missiles. So if you're going to be dangerous enough to attempt this, make sure you wear all your PPE and watch out. Hey, and guess what? That's right, I didn't check it for square before I started laying everything out, and behind the scenes I had to cut these little squares to size on the table saw and make sure that they're actually square before we started. Now I know it's a beginner's mistake, but I'm pretty sure we've all made that mistake before. But now that we got that, let's flip them over and lay them out properly like we should have in the first place. And now that that's all dry, let's take a moment here to do some layout. We're going to lay the outside shape of this whole thing out, which first, we're going to create that first wing, which is roughly about 1/2 inch. Essentially what I'm going to do is I'm going to stripe up the side on the left and on the right, and that's going to give me the lower portion of the layout. Now what we're going to do here is, we're going to pick that top part here, the 650 thou, and we're going to scribe that in there. And then we're going to hit the lower portion and connect the two. So a little bit later on in the year, I want to provide you guys with the blueprints and the STL files for all of this, for free of course. But we got to go back. Remember 2 episodes where we put that clamp that went on the 2-inch or the 1-inch shaft? Well, I want to actually remachine that out of a billet and actually provide the blueprints for free as well with it. But I digress. Let's get back to the project at hand here. Of course, we've got to scribe the center line because a lot of our details are going to come off that center line later. And then we have to connect the 2 little points here at the bottom and the top. These are going to form the wings that we're going to have to cut out later. For the style of machining that I do, I really don't see any point in kind of milling out the keyhole or the holes that we're going to drill later. But one important factor that we are going to do, so we don't get confused, is we're going to put little squiggly lines on the side, just so that we know what the waste is going to be. That way we don't overcut a line and make mistakes and then have to do things over again. Also, I'm going to risk it here. We're going to do kind of a bulk machining thing and cut it all at once because it's going to save us a lot of time in the end. And our first operation in the whole thing is going to just be rough mill everything to the vertical line on the middle of the left there. Now, keep in mind I'm going to zero my DRO as I go so that when I flip this over, I can easily come back to all these measurements and I don't have to kind of reconnect with the lines and everything. That way, if I make a small mistake on this side, which I won't, I can come back to the other side and do the exact same thing so no one will ever know that any mistakes were made. So now that we got that all roughed out, we want to come back to that middle line there, the vertical one, and we want to get that right on as close as we can. So I'm going to loop around here and I'm going to bring the center of the end mill to the front edge, and then I'm going to work my way over to the left until it cuts away that line. And then essentially I just work my way through that axis, make a nice little polished surface, and we pretty much got what we're looking for. Let's clean everything up before we move on to the next stage so that we don't have any little bits getting in the way. Also, one of the cool things here is, because we had that blue layout dye on both sides and possibly a little bit of oil in there, When I compress those two parts together, they're sticking together quite well. We just have to be very careful to make sure that they stay together. Now that we have the height locked and everything zeroed at the DRO, we can put this in and use this parallel as a stop to make sure we get it in the same spot as we had in before. The only problem is the lines are laid out on the back side now, so we just have to be careful to watch all of our digital readout and make sure the table hasn't moved or anything. And like I said, everything's been locked in. We just come back up to the same measurements, lock our table in. Now it's just a matter of steadily feeding it across and having a good surface finish in the end. Now, let's take this out of here and have a quick look. Man, that's looking pretty darn good. I'm pretty happy with the results. Now it's just a matter of cutting that 45 there. And I bet you're wondering how we're going to do this angle, aren't you? Well, that's pretty simple actually. We're going to use this piece of high-speed steel because my parallel was a little bit too high. And we're going to use that as a kind of a gauge block right on that line on the corner. I think you'd be pretty surprised how precise your eye is with lining up stuff like this. So, I mean, if it's just a cosmetic thing, I wouldn't hesitate to try kind of a technique like this. Now, the only tricky part now is as we cut across here, we got to get that height correct, and then we got to not overshoot and cut into that other side with the right-hand side of the end mill. This is just going to be kind of a bring it down to the level, and then we're just going to work it slowly over until we notice that it's got the right angle in there. Oh man, I think it's time for a little bit of maintenance on the milling machine, but let's get this project done and then we can get over to that part of the project. We're not quite there yet. So, like I said, we're going to go low and slow here and we're going to take our time on this, but I'm pretty sure on this cut we're going to have precision and we're going to be pretty happy with this. There we go. That's looking a little bit better now. You guys would be so proud of me. I'm even turning the milling machine off while I put my fingers in there. Safety first, right? Now, let's flip this bad boy over and use that piece of high-speed steel and set our height again. Now, keep in mind, since we didn't touch our height of the knee or the head, we don't have to worry too much about getting the height set. We just got to edge it over to that angle again. And to be honest, I'm pretty darn happy with how this turned out. Let's have a quick look at this. I think that's going to do just fine. Now on to the next operation. Now, if all of the parts were cut correctly, when I clamp this vise down, it should clamp on all four of them reasonably even. If you don't understand what I'm talking about, if one of those is a little bit bigger, it's getting clamped down, and the other three are not getting clamped down. So far, so good. It's looking pretty good. And I'm pretty sure we're going to get away with it this time. Let's take that parallel out from underneath there so we don't drill a hole in the table. And let's cut that groove in there. But before we get to that point, we're going to actually have to find center on this bad boy so that we know where to cut the groove. And as we showed before, it's pretty darn easy with the edge finder. We're just going to bring this bad boy up to the edge till it moves a little bit to the left, zero DRO, or turn it on for that matter, and then come back over to the other side and find the edge on that side. Now, finding center is as easy as grabbing that number and essentially dividing it by 2, right? So half of 1.3 is, I don't know, what's that, 6.5? There we go, 0.65, that's right. But you know what, actually before we even get to that point, we need to measure the screw that we're going to use because we got to figure out how big the slot's actually going to be. And I mean, it looks like it's 300 thou. So what I'm going to do is I'm actually going to find where the hole is going to start. Pardon me, the key slot's going to start. And then I'm just going to drill a hole in that spot. I hope this is making I hope this is making sense for you. Oh, but before I do that, I actually got to grab the edge finder and find the edge on the material. The cart before the horse, right? Except the only thing that I got to remember this time is when I find this edge is I have to lift it up after I find the edge, of course, and move it over that 100 thou. So we're going to zero it here. We're going to bring it up. Simple as that, right? And then we're going to move it over that 100 thou and zero it again. There's been so many times that I forgot to zero it that second time, and I can't figure out where that 100 thou is that we're off. But anyways, I digress. Before we do that, let's spot a center drill on there and just kind of double check our work. Speaking of that, taking the diameter into account, we got to move it over 400 thou from the edge over to here. Now, let's center drill that first, just because I don't even think we need to center drill it because we're just cutting a relief hole here, but let's go overboard and actually center drill this. And then we'll grab that drill, once again overboard, and drill this out so that when you actually cut this slot with the end mill, the plunge motion doesn't make the end mill all walk around and create that kind of keyhole. You remember those old keyholes from like Europe and stuff where there's the big hole and then the groove? Well, we're trying to avoid that here by doing it this way. Essentially, this hole that I'm drilling here is going to provide relief on the center of the end mill, and then when I plunge down, the end mill doesn't walk around. Now it's just a matter of grabbing the right end mill and plunging that in there and cutting this one plate at a time. Now, keep in mind, there's a small little problem that we have here, is the end mill's not quite going to be long enough to get through all of those plates. A small oversight on my point, but you know what, at least we'll cut the first two plates, and then we can pull those out and cut the other two plates. Essentially, it's as easy as just traversing the 1.5 inch now, and we've got our key slot. In case I didn't explain it correctly, the purpose of the key slot is to allow this to go up and down. I mean, this is going to hold the bearings, and in turn, the bearings are going to hold up the crankshaft so that you can spin it on these bearings freely. And we'll get a little bit more into the bearings here in a little bit, but essentially these bearings are going to have a concave top, concave top. I always get confused with that. And it's going to allow less friction for this crankshaft to actually spin so that we can check it with the dial indicators. Let's pull this out of here and have a quick look at it. I mean, it's looking pretty good. It's actually starting to look like it's supposed to. I mean, not that we had any doubts, but it's actually starting to take a little bit of shape now. Now, I'm just going to quickly bang through these other two here, but while we're doing that, let's talk about a couple little things. In case we didn't say it already, the key for having these parts, all four of them, fitting together and the vise actually clamping them down was to have all four of them exactly the same size. Remember, if we had one of these a little bit bigger or a little bit smaller, while we're using this end mill to cut through stuff or drilling or tapping, one of them would come loose and you'd start to see it work its way, out of the wafers in the middle, and essentially would probably end up breaking an end mill or something. But not today, my friend, not today. This is fitting up really nice here. You know what? I think this is going to be a pretty good little project. I think the only one thing we could do different with those screws is have a little bit of a shoulder on them. But without further ado, let's take a look at the bearings and fit everything up here. I got a little trick to show you if you don't know this one already. We need to figure out the distance between the two centers. So what I'm going to do is I'm going to measure the inside of this one bearing. Then I'm going to gently push these two bearings together. And then we're going to measure again. And that's going to give us the distance between the two bearings. And then, of course, we're going to have to add a little bit of play in between them. So that gives us about 1 inch and 650 thou. Now, all we have to do is divide this by 2. And then we move our Y, the 850 thou or 825, into the negative and into the positive. And that'll give us the center points for our Y. Then we have to figure out the X. Well, that's pretty easy. We're just going to touch off on the edge here with the edge finder, zero it, then we're going to lift it up, move it over that 100 thou and zero it one more time. And for some reason, I thought 300 thou would be enough moving it over, and it's not quite enough. It looks a little bit too close to the edge here, and I want to move it over just a little bit more. So, in the true spirit of making things, we're just going to do it by eye, and then we're going to add the measurement in after. Right, another 75 thou, that never hurt anyone. Then we're going to take a little peck on it, and I want to make sure that these two are even. Right? Those two distances are even because we want it to kind of look symmetrical, right? And we want a good face for that bearing to actually bolt onto. So now that we got everything center drilled, I'm going to move over to putting the screw in. Now, notice how this has the V-shaped head on the screw, and it fits perfectly in the head of the bearing, which will center the bearing in the center where we want it. Now, remember the taps that we talked about in the last episode that showed up the next day? Well, they're here now, and it's the next day. And boy, am I glad to have these. Although, it's almost like I have too many options now. Let's grab the tap out of the package and make sure that we have the right screw for the job here. And it's as simple as just putting the threads up against each other and seeing if there's any gap in between them. Bingo bango, we got the right one, and this is what we're going to go with. And of course, let's just double check to make sure we got the right tap for the right screw, and double check that as well. And just like last time, it was an F, and we're going to pull that bad boy out and use her one more time. So the next step that we're going to have here is we're going to break out one of my favorite tools. This is the new tool that I got. You know, the one that you can tap with and it clamps into the head of your drill chuck. Man, I'm just really loving this tool. This is honestly, if you're to go out and buy an extra tool this year, if you do tapping in the mill machine, this is probably your one, man. Like this is like the bee's knees, I think. I'm not too fucking sure, but either way, it is a fantastic tool, and it comes in a set of three, or you buy 3 of them, and you got it for everything you need, and there's no more crooked holes. And not to mention, it's pretty damn simple to use, that's for sure. You just lock the top, make sure you got a bit of gap for going up and down, and bingo bango, man. And the other thing I'm pretty sure you guys noticed is I got a little risky, and I'm going with a bottoming tap on here. Don't ask me why I picked the bottoming tap. Complete total mistake. Right out of the gates, I can feel that there's way too much torque cutting on there, and we need that gradual start to get it to go through there. So let's take this all apart and use probably the proper tap for doing this job. I mean, ideally a bottoming tap is for bottoming. I mean, you tap it with one of the first 2, and then you finish it up. You take the other one out and finish up with that one. But we've already got a problem as it is here. Because it's not a bottoming tap, and because of the space, we're only going to be able to tap, once again, just like cutting with the end mill, we're only going to be able to tap into 2 or maybe the 3rd part before we kind of lose the threads. But really, that's okay. We can take this out and move it around to the other one and tap those other 2 at the end. I mean, essentially, once we got those threads started, and we got it bolted in there, it's pretty darn easy to go back and tap the other bunch. So now I'm pretty sure you guys realize that we're getting close to the end here, but we forgot one really important thing. You see, we need to put a little divot in that plate because if we get a small crankshaft, it's going to ride on the top of that plate where my thumb is. So, in the true spirit of everything, we're just going to throw an end mill at it and, and gouge out along the center and make sure that's not a problem down the road. So now that we got this done, I'm going to take this out and deburr it, clean it up, and actually polish it off camera. And I'm pretty happy with the results. But now let's talk about a couple quick things while we're assembling this. Now remember, the screw that I'm putting in here has a taper on it, which is gradually going to pull that bearing into center of the actual screw hole that we have. Hey, and also don't forget, this channel runs on likes and subscribes. Don't forget to hit that like button, because that like button drives this channel forward to make cooler and cooler stuff for you guys. I hope you guys enjoyed this, and if you like this, check out the next video that we have coming up. It's going to be a real sweet one. This is going to be the one where we actually machine the last casted part, and we're going to assemble the whole crank truing stand and actually throw a crank on it and give it a whirl and see how it all works out.